Hello student, Assalamu alaikum warahmatullahi wabarakatuh. This is Raid al-Malki. I'm going inshallah to teach you power electronics. It is electrical course. Its code is triple E 203. This is for lecture number 1. Now, let's just only briefly talk about the course content, inshallah. For week number 1, we are going to have an introduction about the power electronics. We will see some types of static switches like transistors, power diodes, and so on. In week number 3, we will inshallah introduce to you the uncontrolled rectifiers like single phase, half wave. In week number 4, we will go to full wave rectifier. Inshallah, also in week 6 and 7, we will go through the 3-phase, half wave, and full wave rectifiers. Now, week 9 and 10, we will go through controlled rectifier. Now, we will go one by one, inshallah. Don't worry about it. I am going to explain in depth each topic. Inshallah, I'm going to record the videos like this, and I will post it to your account in Blackboard. Now, also in week 10 and 11, as I said, we are going for the controlled rectifiers like single phase, 3-phase, half wave, and full wave. For week 12 and 13, we will see how the DC choppers are working, the principle of operation, and we will see the types of DC choppers. In the last week, we will just take an introduction about the inverters. Now, as you can see here, guys, now this is the reference book, textbook that we are going to use. You can bring your textbook to be a reference for you in this course, and inshallah I'm going also to submit to you a handout. Inshallah, it will help us in explaining more concepts of power electronics. Now, lecture number 1, it will be about power electronics introduction and static switches. Now, we are going to outline introduction about power electronics. We will see the concepts of power electronics. Inshallah, we will go through converter classification. We will introduce to you electronic switches like diode, thyristor, transistor, and so on. We will show you important notes for the transistors, and we will go through homework, and this homework is not required to be submitted. I'm going just to give you questions. You need to answer them by yourself, so it is not required in the course. Okay, this is just to make you practice more about the power electronics. Now, what is power electronics? This is the basic concept of power electronics is just it is involving the study of the circuits intended to control the flow of electrical energy. So these circuits handle power flow at level much higher than the individual device rating. So sometimes the power electronics we use them in order to control much higher power rating. Let's say I have a relay with 5 volt, right? And this relay is closing and opening a line like a circuit breaker or magnetic contactor for 120 volt or 220 volt. So 5 volt is controlling that much higher voltage level. So it is the same concept here. We are controlling much higher power ratings devices by using power electronics. Now, what is power electronic circuits? Now, this is very important. Now we are talking about the circuits of the power electronics. So the power electronic circuits, it's converts It is converting electrical power from one form to another using electronic devices. So we are now, you can underline the word form, and we are going to convert from one form of energy or one form of let's say an AC alternating current to a DC current. This is the basic concept of power electronics circuits. So we are going to convert from one form to another form using electronic devices. Now, what is converter? Converter is the power electronic circuit converts one type of or level of voltage or current to another, like the diode. You remember in the course of electronic we have taken it is 4 credit course, and you have taken in electronics diode, and also you have taken the transistor and so on. So you have taken the diode, but here in power electronics we are talking about power diode. Now forget about the diode, now we are talking about power diode. Why is that? Because it can handle much high power. Okay. As we said, you used to handle diode with 5 volt and so on, and inshallah in this course we are going to handle 120 volt and 220 volt and so on, and much higher power rating and voltage rating. Now the converter basically it is divided into 4 types: AC to AC converter, AC. So we are when we convert from one type to another type, okay, like AC to AC, then it is called converter, right? Even if we are going to convert from AC to DC, DC to AC, so the name converter is covering all these types, covering all these 4 types. So now for AC to AC converter, this is we will not go through it. It is by using a regulator or cycle converter, and this is not required in our course. Okay, now let's go to AC DC rectifier. Now when we going to convert from AC to DC, this is very important. Now when we convert from AC to DC, then we are going to use a rectifier like the diode. You remember the diode symbol, like this. This is the anode and this is the cathode. So when we are going to convert from AC to DC, we are naming this type of device is a rectifier, okay, like the diode. And inshallah I'm going to explain everything about the AC to DC. And this rectifier here, we are focusing on this part of the converters for the whole semester. Inshallah we are covering rectifier maybe 7 topics for the rectifier. So the rectifier is very important to be understood. خلاص. Now and then after we finish inshallah from rectifier, we will go through a DC to DC converter. It is like it is called a chopper, DC DC converter. So it is called chopper here. Here we call it rectifier, here we call it inverter, and here we call it chopper. So DC to DC chopper we are using to step up the voltage, we call it boost, and step down the voltage, we call it buck. Now just let me bring my papers here. DC to DC. So when you are talking about DC to DC converter, we are dealing with DC voltage fixed as an input and DC voltage variable output. So we are varying the DC input by boosting up the voltage or by bucking down the voltage, Basically, it is the same concept of the transformer in AC, but this is in DC, okay? This is in DC, so we cannot say it is a transformer, no. The name of the DC to DC converter is chopper. The transformer is already, you already know it, and it is stepping up, stepping down the voltage and the currents in AC circuits. خلاص. Now finally we are going through the inverter. Now basically almost all the supplies like generator, AC generator, like other generators, we are producing AC power, right? We are using alternating current. Now, as you remember, if you have heard about the solar energy, so we are using PV panels, right? Now, those PV panels are going to collect the power from the sun, from the radiation of the sun. Now, the voltage that comes out from the PV panels is DC, right? It is DC volt. Now, DC, we cannot use it with AC AC device, right? So we need to convert the power from DC to AC. Now we call it inverter. So we need to invert the power from DC to AC. And this is the last topic. Inshallah, we will cover it in this course. Okay. Now, as you can see here, this is our supply, which is AC, right? And here our second supply, which is DC. Now this is a block diagram. As you can see here, this is a block diagram of converting from one source to another, from AC to DC, from DC to AC, and so on. So this is in general called converter. If we need to change the power from AC into DC, then we call it rectifier. If I need to go back from DC to AC, then we call it inverter. As simple as that. Now, for the static switches, or we can call it electronic switches. So from its name, it is electronic switches. So those switches are characterized by having two states, which is on and off. It is like switch, okay? Normal switch, right? So it is by on or off. Now this is off condition. If we close it like this, then it is called on, right? Now we can say that this is a short circuit when the state of the switch is on, then it is short circuit. Okay, when the let me just take another color. When the state of the switch is off, we can say it is open circuit, like this one. So it is open circuit. Now this is the basically the electronic switches. Okay, now let us divide our static switches or electronic switches into very brief two types. Like this is called controlled, and we will inshallah understand why it is controlled, and this is called uncontrolled switches. Okay, we will see how we can control, why it is not controlled, and so on. خلاص. Now if you are going to use the uncontrolled switches, of course we should talk about the diodes. Now the diode, either we have full wave rectifier or half wave rectifier, so we cannot control the diodes. Okay, now this is our first part inshallah. in our course. Inshallah, we will take the single phase. Let me write it here if you want. Now for the diode, we are going to see the single phase half wave rectifier. This is one, and inshallah in the next lecture we will go to single phase full wave rectifier, and we will go to three phase half wave rectifier, and we will go to also three phase half full wave rectifier. So for the diode, we have four topics. For the diode, we have four topics: single phase half wave rectifier, single phase full wave rectifier, three phase half wave rectifier, and three phase full wave rectifier. And this is uncontrolled switches. We cannot control it by ourselves. Then inshallah, after we finish from the diode, and the diode already have taken it in electronics, as I said, inshallah we are going to do the same thing, okay, the same concept for those topics. We will do it the same for the controlled in the thyristor, inshallah. So this thyristor, basically it is the same as the diode, except the thyristor is controlled. Okay, and again inshallah I'm going to explain why it is controlled, inshallah, in the coming weeks. Now the control part here, let me just erase those ones here. Now for the controlled switches, we have transistors, we have thyristors. Okay, transistors, we have three types. We have BJT, which is bipolar junction transistor. We have an IGBT, insulated gate bipolar transistor, and we have the MOSFET. Now the MOSFET is very important for us. We use it for the DC to DC converter, DC to DC converter. Okay, between brackets it is chopper. Okay, now this is for the transistors. For the thyristor, okay, and now we are talking about tri-junction devices. Now let me explain this term. This is very important. In diode, we have p-n junction, right? Remember p-n junction. So we have holes and we have electrons. So electrons is going from the N to P junction, because P is holes and N for the electrons. So we will have current going through the diode. Inshallah, I'm going to explain it. So if you have forward bias, then the current will go. If you have reverse bias, the opposite side, then the current is not going to go through. Now for the transistor, is we have a dual junction, BNB, PNP junctions, or we have NPN junctions. Okay, so we have dual junctions here. In the transistor, we have tri-junctions. We have 4 layers, P, N, P, N. Okay. Now for the transistor, we have many types, but the most important thing, which is the SCR. SCR is very important for us. Inshallah, we will use it instead of the diode in controlling our circuit. Okay, so this is SCR. SCR is the meaning of or it stands for silicon controlled rectifier. Silicon controlled rectifier. We will go also through the Ghetto, gate turn off thyristor. We will go through the MCT, which is MOS controlled thyristor. We will go through the diac and triac. Okay. This course or this lecture is going to be an introduction for the whole switches, the electronic switches. You are responsible for knowing the name of the electronic switches and the symbols of the electronic switches. Now, you can find this table in your handout. Inshallah, I'm going to send it to you. This table is very important to show you the symbols of our electronic switches, like the diode. As we said, this is the diode here. So this is the symbol of the diode. We have anode and cathode. Anode is positive, cathode is negative, right? So when you have power supply here, I will just give you introduction. When you have power supply here, positive and negative, then we have forward bias. And when you have opposite, which is negative and positive, then it is reverse bias, and the current is not going through the diode. Now, for the transistor, BGT is the one that you have taken in electronics, which is basically having three terminals, which is base, emitter, and collector. Base, emitter, and collector. The IGBT is again this symbol, the same as the BGT, but it has different type. So the IGBT is the combination of BGT and MOSFET. The combination of BGT and or BGT and the MOSFET. Okay, so this is the IGBT. Now the MOSFET this is the symbol of the MOSFET. Please make sure that you know how to draw it. You are going to be asked in the exam, either the quiz or the midterm or final. And let's go for the transistors. We have SCR. So SCR, now this is the diode. Okay, this is the diode, the symbol of the diode. Now for the SCR, it's the same symbol. Okay, but we have a gate. We have here a gate, G. So we have three terminals, G and anode and cathode, right? So it is the same as the diode, but it is controlled by a gate. Controlled by a gate. And this is the Ghetto. This is diac. Diac is basically two thyristors in opposite sides, and triac also again. It is having three types. Triac is three types. We have transistor and we have thyristor. We will see, inshallah. We'll go one by one, inshallah, in the coming slides. Now, let's talk about the switch, the concept of the switch. Now, as you can see here from this graph on the right hand, or this diagram, or this circuit, we have here 25 volt, right? And here we have 500 ohm resistor. And this is our switch. Okay, now let us talk about the power control of switching. Now let us understand what is switching. What is switching? Okay, switching, let us assume that I need the switch to switch on when the time is reaching 2 milliseconds and switch off when the time is reaching to 8 milliseconds. And again, it will start from 10 milliseconds and it will be off at 16 milliseconds. So do you think I can do it manually? Do you think that I can switch on and off manually in milliseconds? Of course not. So no human being can handle milliseconds. Okay. Now, this is an ideal control switch. It is basically power semiconductor device. Semiconductor. When I say semiconductor, means it is not. It is neither conductor or nor insulator. Okay. So it is semiconductor devices like the diode and so on. It has a switching pattern, as we said, explained. Now, what does the expression ideal switch mean? Now, let us go through these conditions in order to have the switch is ideal. We don't have losses. Now, he said when the switch is ideal, means that there is no power dissipation, no power loss. When the switch is closing, this is the switch. When we close the switch and open, close and open, close and open, we don't have power loss. And this is not the reality. And he said that this is the ideal switch. Okay, the ideal switch. So in ideal switch, we don't have power loss. We have zero switching time. يعني it takes 0 seconds in order to close and open, and this is of course not real. We cannot reach to this this ideal switch. And also, if it is on, it has zero impedance, and it has zero voltage drop. Of course, if it is open and we don't have if it is on, so it is short circuit, right? If it is on, it is short circuit. So it is like a wire, right? We suppose that we don't have here impedance, we don't have here resistance and impedance in general, and we don't have here voltage drop. If it is off, it has infinity very high impedance and the voltage drop across its terminal equal to the supply voltage. If we don't have voltage drop, it should have the same supply voltage. If we have it here 25, if the switch is open circuit, then we should read here 25 volt, right? And this is the ideal. I just want you to understand what is switching here in this slide. Now, let's go to the concept. If you remember in electronics and circuit 2, we have the waves, right? This is the wave waveform, and this is one ripple. We can call it, this is one ripple, and this is half of the cycle, right? This is half of the cycle because it is a cycle is starting from 0 and ending to 2 pi, right? And this is 180, which is pi. So this is one cycle. We can say that sorry, this is half cycle, and we can say that the firing angle is here. Why is that firing? What do I mean by firing? Firing angle, it's like ignition angle when the wave is starting, right? So the alpha is called the firing angle. It is the time at which the power electronic switch start conducting current. So when this is the current, okay? Usually the current is half of the voltage, right? You should know this. And this is the current. So the current, when the switch is conducting the current, when it is closed, then alpha is the firing angle. Now, beta is the commutation angle. It is the time at which the power electronic switch stops conducting. So when the switch is stop conducting is here. So at 180, which is beta in this case. Okay, pi in this case, sorry. So this is beta. Now gamma is basically the conduction angle. The conduction angle, which is beta minus alpha. So it is the time at which the power electronic switch is conducting the current. So the current is conducted from here up to here, right? So this is the gamma. This is the gamma. Okay. Now this is just only to remind you about the angles alpha, beta, and gamma in AC circuits. Now, for the diode, now this is the first part, and this is like the diode in electronic course, but this is now power diode. We are talking about power diode. Okay, power diode means it can handle more or a huge amount of voltage and current, right? So a diode is the simplest electronic switch. Okay, it is uncontrollable. This is very important, shabab. We should you should underline it. It is uncontrollable in the on and off conditions. So we cannot control the on off conditions by the voltage and the current. The diode is forward bias, which is on, when the current ID, okay, in this figure A, this is the current, huh? Is positive and is positive. Okay, so when we have as you can see here, we have here anode, here we have cathode. If we have plus from the supply to the anode and negative to the cathode, then we have forward bias, the current will go through. Now in the reverse biased, which is off, the VD is negative, the voltage is negative, so the voltage from the supply will be minus here with the anode and plus with the cathode, and then the current will not go through. So in ideal case, the diode is short circuit when it is forward bias, and open circuit, so there is no current will go through in reverse bias. Now this is the characteristics of the voltage and current here for the diode. This is the V diode, right? V diode, and this is the current I diode. In this portion, okay, in this portion, the diode is on. The diode is acting as on switch, okay. So once we reach 0.7 volt, as you remember, then the current is starting conducting the whole current, okay, and this is going up. But in the reverse direction, this is in reverse direction, it is off, and this is ideal. This is ideal graph, ideal characteristics. Of course, it will not be like this. It will be a little bit down here. But we need to show you the ideal graph in order to understand everything. Okay? So the ideal graph is when you apply voltage plus minus to the diode, then it is forward bias, and then it is going to start conducting the current. When it is reverse bias, it is not conducting the current. So the characteristic is on with the current here on this side, which is forward, and this side is reverse biased. Now for the diode, we have types of power diode. This is just only to show you. It is not very important. This slide is it's not very important, but at least to show you and give you the sense of the power diode. Okay, now we have three types of the power diode. We have general purpose, we have high speed, and we have Schottky. Now the ratings, this is the difference between the three types. So the ratings is different. So in general purpose power diodes, we are reaching up to 3000 volt and 3500 ampere. So it is very huge voltage and very huge current. In high speed power diodes, we are reaching to 3000 volt and 1000 1000 ampere. Schottky power diodes. This is the name of the application. Okay, it reaches to 40 volt and 60 ampere, and we have many types. As you can see here, we have many configuration, like the disk type. We have the stud type. We have this type, dark band, and the dark band is for the diode. A dark band means it is this type is the cathode. When we see the dark here, dark band here, this is dark band. When you see the dark band for the diode, means this is the cathode and here is the anode. So this is the symbol, huh? Okay, make sure you understand يا شباب, because you will see it inshallah in the real life. And this is another type of the diode, which is like screwed, huh? Like screw. Like screw. So this is for the cathode and here is the anode. Now, the second part of our lecture today, it is about the thyristor. It is about the thyristor. Thyristors are electronic switches used in some power electronic circuits where control of switch on is required. Make sure you underline this part here. So the thyristor is controlling the switching on. The switching on of the switch is controlled by using thyristor. Okay, so the thyristor is controlled in turn on conditions. Turn on conditions. خلاص. It is referred to a family of 3 terminal devices. Okay. Because it has 3 terminals, so it is with a family and include silicon controlled rectifier, as we said, SCR. We have Ghetto, we have MCT, and we have MCT. Let me just go back to make sure. Dia can try also, yes. Now, the name of the SCR or thyristor is used sometimes and the most common name is thyristor. The most common name is thyristor, or we can say silicon control rectifier. Okay, the thyristors are capable of large current and large blocking voltage for the high power applications. So it is used for high power applications. Now, let me just highlight, this is very important, but switching frequencies cannot be as high when you're using other devices like MOSFET. So MOSFET is very good in switching frequencies. When I say switching frequencies, it is the number of switching on and off, okay, switch on and off. This is the switching frequency. The switching frequency, MOSFET is much high switching frequency. Of course, we have drawbacks for the switching frequencies, but inshallah you will understand it. But for the time being, you should understand that the thyristor is capable for large currents, and the MOSFET is good in switching frequencies. Basically, it is silicon-based semiconductor device. Okay, and this thyristor is used to control in DC and AC systems. Silicon controlled rectifier is widely used. Okay, as we said, the term thyristor is more common than the SCR. This is just only general information. We will use the term SCR and thyristor for the same device, of course. Okay. Now, thyristor, as I explained, we have 4 layers. Let me just take another color. We can use the yellow one. Okay, now, or yeah, just use the blue. Okay, so we have 4 layers, which is P, N, P, N, right? We have 4 layers. Now, how much junctions? We have 3 junctions. This is junction number 1 between P and N, right? It is, here we have junction number 2 between N and P, and here we have junction number 3, which is between P and N, right? So J3, J2, J1. No need to understand how the thyristor is working, and because it is about chemical reaction, and we are doping some electrons inside the thyristor in PN junctions, and it is very complicated process. So just make sure that you understand that we have 3 terminals: anode, cathode, and gate to control, right? So this is the gate. Can you see here? This is the gate, okay, of the thyristor. SCR ratings improved in introduction to now SCRs of the voltage rating of 10 kilovolts. So it is very huge voltage, and we are using thyristors. What يا شباب, you remember, to as a rectifier to rectify AC circuit into DC circuits, right? But it is controlled. Now, such a high power thyristor can be switched on by a low voltage supply, about 1 ampere and 10 watt. So we are controlling. So the gate is responsible for switching on. Okay, switching on. Remember, Shabab, in thyristor we are not switching off. We cannot control switching off. We are controlling only switching on, right? So the gate is responsible for switching on, and the power is basically 10 watts for the ratings of the 10 kilovolt. So it is very small gate current in order to switching on the thyristor. Now, this is basically type of the SCR. So we have 3 legs. Usually, the gate this is the flat face of the thyristor. Usually, if you see the flat face here, then you can start from the left side: cathode, anode, and gate. Okay, this is the flat part of the thyristor. If you see like this thyristor, the screwed part here is anode, and the long one is the cathode. The gate is the smallest part here. Okay. Now, SCRs are solid state devices, as we said. They are compact, possess high reliability, and have low losses. They are almost universally employed, of course, as we said. And this here is called because silicon is for construction, and its operation as rectifier can be controlled. This is more clarification for the previous slides. Like the diode and SCR, this is very important, is unidirectional device for the current and the voltage. It is unidirectional. It is one way. So if we have an AC circuit like this, so this is AC. Why is that? Because it is alternating wave, right? It is alternating between the plus and the minus. For the thyristor and the diode, it is the same. So we are controlling the current and the voltage are unidirectional. So it cannot go to the negative. No, it cannot go to the negative. So it is positive only. This is just only for the single phase. So this part is going to be removed by the diode, and also it is going to be removed by the thyristor, but the firing angle is different between the thyristor and the diode. Now, this is the SCR. Please try to read here the graph, the paragraph, and if you need to understand the VAK, it is the voltage anode to cathode. The voltage anode to cathode. If it is exceeding the threshold voltage, then the thyristor is conducting. And as I said, it is not important for you in this stage to understand the concept of conducting the thyristor, either SCR and Ghetto and so on. For the Ghetto, now, Ghetto, it means gate turn off thyristor. Gate turn off thyristor. So it is like the SCR, but is turned on by short duration gate, and if the anode cathode voltage is positive. However, unlike the SCR, the Ghetto can be turned off. Can be turned off with negative gate current, okay, through the gate, of course. Therefore, it is suitable for some applications, okay, where control of turn off and turn off of a switch is required. Then we use Ghetto. Now, let's go back to just remind you about the diode. Diode is not controllable, okay. Then we have thyristor, which is controllable for switching on, okay. The Ghetto here is controlling, it can control the on position and the off position of the switch, okay. So this is the difference between the diode and thyristor SCR and the Ghetto gate turn off thyristor. Now, for the Tiriac, the Tiriac is basically a thyristor that is capable of conducting current in either direction. Why is that? The Tiriac is functionally equivalent to two anti-parallel SCRs. So, as you can see here, we have two anti, means it is in other direction. They are parallel. Okay, so this is one. This is one thyristor, right? Remember, we have here gate, and this is another thyristor. So they are parallel. Okay, they are parallel, SCRs, and they are opposite in direction. So it has a very cool advantage. It is used commonly in incandescent light dimmer circuits. Use a triac to modify both positive and negative half cycles, so we can control the half cycle for positive and negative half cycles. So from where to start? This is a very good example, inshallah. If you understand it by yourself, it is not required in this course. Tiriac, inshallah, we may not cover it in this course. Now, MCT. But if you have any questions, please refer to me. I can answer you. Now, for the MCT, it is the MCT is functionally equivalent to the Ghetto, okay, but without high turn-off gate. Without high turn-off gate current required. Now, remember, we need to, in Ghetto, we need to have a high turn-off current, and here we don't have, okay. Basically, the MCT has an SCR and two MOSFETs integrated into one device. So if I ask in the exam, what is MCT exactly? You can say it is one SCR and two MOSFETs integrated into one device, okay? This is very important. Now, the note here is also very important. Thyristors were historically the power electronic switch of choice because of high voltage and current rating available. Thyristors are still used, especially in high power applications, but ratings of the power transistors have increased greatly, making the transistor more desirable in many applications. Now, to conclude the thyristor, Shabab, inshallah, if you go to the industry, you will see that they need to control DC motors or DC motor. Then they are going to have an AC supply converted to DC through the thyristors. Okay, they are using thyristors. So the thyristor is most common electronic switch in the industry. Now, the final part of our lecture today is about the transistor. Transistor is electronic also the circuits. Transistor designed neither fully on or fully off state. It differs from the transistor applications such as linear amplifier circuits and so on. Now let's go to directly to the types of transistors. We have two types mainly. We have bipolar junction transistor that you have taken in electronics, which is NPN type or BNP type. The second part, which is inshallah you are going to cover it here in our course, which is field effect transistor. Field effect transistor, FET, it is called FET. And we have two types. We have junction type, we have MOSFET. So this junction type, of course, it is depending on the depletion region, if it is N type or N channel or P channel. So forget about it now. We will not take it. We are concentrating on the MOSFET type, and we are concentrating also for the enhancement type for the N channel, So we will not take depletion types and so on. So we will take, let me just do it by another color. We'll take transistor, field effect transistor, MOSFET, and enhancement type N channel. Okay, so we're concentrating on this part. Sorry. Now for the transistors, unlike the diode, turn on and turn off a transistor are controllable. Okay, the types of transistor used in power electronics circuit include MOSFET, bipolar junction transistor, BJTs or BJTs, and hybrid devices. When I say hybrid, it is meaning that we are having MOSFET and BJT together in it, and it is called insulated gate bipolar transistor, junction transistor. So as you can see, here is the MOSFET. It is N channel. Now the MOSFET, this is the symbol of the MOSFET. This diode is theoretically is there due to body. It is called body diode. You will understand, inshallah. For the BJT NPN, this is our collector, this is the base, this is the emitter. So either it is fully open or fully closed. Fully open or fully closed. It is not like the transistor we can control if we need to start the firing angle from 0, 1 to 20, 30, 40, 90 degree. Okay, here either it is fully open or fully closed. And this is for the IGBT symbol. It is basically the combination of MOSFET and BJT. Now, Alhamdulillah, before we finish from this lecture, I need from you to understand some important notes for the transistor. So we need to understand that the MOSFET is a voltage control device, while BJT, let me write it here, BJT is current controlled device. Okay. MOSFET switching speeds are greater than those of BGTs and are used in converters operating in megahertz ranges. So it is very huge range, right? Now, for the power, BGTs are rarely used in new applications, being surpassed by the MOSFET. So the MOSFET and IGBT is mostly used in industry. As I said, the IGBT is integrated connection of MOSFET and BJT. This is very important, shabab, to be understood, inshallah. Now, last thing is the homework. We have 5 questions here. Please try to answer them. Refer to the textbook. Refer to the textbook in order to answer the questions. If you find problem with the homework, please come to me in the discussion class, and then inshallah I'm going to explain the questions. سبحانك اللهم وبحمدك أشهد أن لا إله إلا أنت أستغفرك وأتوب إليك. This is the end of our lecture today. Inshallah, our way of teaching is to upload for you the videos and the slides. After that, inshallah, in the coming class, you will have a discussion in order to finish to answer all your questions and concerns about the previous lecture. Please follow the course semester plan and watch for the Blackboard account. So make sure that you follow the Blackboard account announcement and everything, shabab. It will be for inshallah for this semester using the Blackboard. Thank you so much for attending this lecture, and see you later. Stay safe.